Hello there and welcome to the Year 9 end of year exam revision video. Here we're going to go through the fourth video out of 4, and here we're going to go through the last questions in the end of year exam. So how do you use this video? Each question, pause the video and answer the question. Give it a proper go, try really hard, not just 20 seconds and then give up. Then play the video and see if you were correct, and if you weren't, then try to remember what you need to do so that you know next time, or try the question again the next day to see if you've got the question correct. So as I said, we're going to go through the last 3 questions, questions 10, 11 and 12, on rearranging formulae, similar triangles and cumulative frequency graphs. Maybe you've watched the Maths Watch clips beforehand, but whatever you've done, make sure you write down the most important ideas on a revision sheet so that you've got something to be prepared with but just before you go into the exam. Okay, so we're going to go through rearranging formulae first. So in each question, there's quite a few that are coming up, by the way. Rearrange it to make X the subject. Pause the video, give these few a go. Alright then, so in these first beginner ones, generally the idea is that you follow the reverse order of BODMAS. Okay, so how do you do that? Well, I'm looking at X. I need to make X the subject. I need to make it X equals. So I'm looking at what's attached to X. I've got a multiply or I've got an add. Now, the way we're going to rearrange these formulas is we're going to start from the bottom of BODMAS and work our way up. And the first one I get to is add, because I have an add in my formula. I don't have a subtract, so I'll skip past subtract and then I've got an add. So I need to undo the add. So how do I undo the add? I subtract, because subtracting is the opposite of adding. So I'm going to take away b from both sides. So on the left it's y, take away b, so that's y minus b, equals on the right 5x plus b minus b. These two things will cancel each other out, so I've now got 5x. Okay, start from the bottom again, and I've got no subtracts, no adds, but I do have a multiply, the multiply by 5. And what's the opposite of multiplying by 5? Dividing by 5. Excellent, so divide by 5. On the left hand side it will be y minus b divided by 5. And on the right hand side, the times by 5 and the divide by 5 will cancel each other out. So it's just x. So my answer is x equals y minus b divided by 5. In question 2, we have a negative in front of the x. It's negative fx. And whenever this happens, the first thing I like to do before I start to think about BODMAS is I like to add that element to the other side, because I always prefer it for my x to be a positive value. So I'm going to do the opposite of taking away fx, which is to add fx to the other side. So add fx to both sides and it will cancel it out on the right and it will appear on the left. So y add fx equals e, and the minus fx will cancel out with the plus fx on the right hand side. Now I can start from the bottom of BODMAS and work my way up. I've got no subtracts in this formula, but I do have an add. So I need to sort out the add first. I've got fx is being added by y. So I need to do the opposite of add y, which is take away y. So my answer is going to be y, take away y will cancel out. And I'll have fx left over. Then it's going to be e take away y, so e take away y. Then I'll start from the bottom. I've got no subtracts, no adds, but I've got a multiply. So I'll do the, because I've got a multiply by f onto x. So what's the opposite of timesing by f? Dividing by f. And that will cancel it out on the left hand side. So I've got x equals e minus y divided by f. And there we are. That's the answer to the question. Let's move on to the next one. Okay, so moving on to the next question, pause the video and give these 2 a go. I'll now get started. So it's going to be y equals, and then we'll open up the brackets first. So 9b minus 9x. The next thing I need to do is I see that my x expression is a negative. So the best thing to do here will be to add it onto the other side. So add 9x onto both sides. And there we'll get y plus 9x. Because I'm adding 9x onto the left hand side, y add the 9x is y plus 9x equals 9b. So 9b minus 9x, add 9x. These two expressions here will cancel each other out, and there we are. The next thing I need to do is I'm making x the subject, so I need to take away y from both sides. So minus y and minus y. On the left-hand side, the positive and negative y will cancel out, so that'll leave me with 9x equals 9b minus y. And the last thing to do will be to divide by the 9, so divide by 9 on both sides. That will cancel out the divide by 9 and the times by 9 to leave me with x equals 9b minus y divided by 9 as the final answer. You could have also had a very similar answer, which would have been b minus y over 9, which would have been absolutely fine as well. So both of these answers here are correct. Moving on to the next one, we'll times both sides by 7 as the first move. Because what's happens on the top, the reason I wouldn't add x first is because whenever you've got two things that are either added or subtracted on the top, effectively they are surrounded by some invisible brackets. And mathematicians won't write out these brackets, but when you can see that everything is all being divided by 7, it's all of this in brackets divided by 7. And when we follow the reverse order of BODMAS, then we would always touch the brackets last and sort out the division first. So the opposite of division is multiply. That's why I'm going to multiply on both sides to cancel out the divide by 7. So now I've got a minus x. On the left I've got 7y. And now I won't include any brackets on the right hand side here, because then that would be everything on the right hand side in a pair of brackets, which would be pointless to do. Now I can see that my x is a negative expression, so I will add it to both sides. Add x to both sides, and I'll get 7y plus x equals a. The next thing I'll do is I'll subtract the 7y because it's being added on to the x. So those two expressions there will cancel each other out, so x will equal a minus 7y. On the right hand side, and there we are. That's the answer to this question here. So with the second one here, I just want to really emphasize that you don't add the x first, and with this expression here you don't add the x because they are still inside some brackets. In the first question you needed to divide, so you need to expand first, and then in the second question you need to multiply by 7 first. Okay, let's move on. Pause the video, give this one a go. Alright, classic mistake students make in this first one here. The first thing I'll do is I'll write out my BODMAS again. And I'll start from the bottom. So the first thing I get to is an addition of a squared. So the first thing I'll do is I'll take away a squared to the other side. And that will leave me with x squared, because the a squareds will cancel out on the left and the right. X squared equals b squared minus a squared. And then the next thing we do is start from the bottom and we get up to O, which stands for powers or order. And we undo the square, and this will be to square root both sides. So this is going to be x equals, and right, watch the incorrect answer. The incorrect answer will just be b minus a, and just square the two things separately. No, you can't do that. That doesn't work algebraically, because otherwise Pythagoras' theorem, the very intelligent man that Pythagoras was, would have just simplified his formula to a plus b equals c. Instead, Pythagoras knew that you couldn't just simplify squares. You actually have to keep them squared and then do a big square root round the side. And that's the only correct answer in this question. You can't just simplify the big square root and the two smaller squares. Maths doesn't work like that. Alright, let's have a look at the next question here, and we'll start from the bottom of BODMAS. Now, anything inside the brackets is protected by the brackets. So I'll start from the bottom, and the first thing I actually get to is the powers. That's the only thing on the outside of the bracket that I can touch at the moment. So I'm going to square root things first. So I'm going to square root both the left and the right hand side. On the left it will be square root of y, and on the right the square and the square root will cancel each other out. So I'll be left with 7 minus x over 2. And I'll have brackets around it, but because the whole thing is surrounded by a bracket, it's effectively useless. Now I spot that my x term is a negative expression, and as soon as I see that, I add it to the other side. So I'm going to add 2x to both sides. So add x over 2 to both sides. So my left hand side is going to be the square root of y, add x over 2 equals, and then 7, because I'll have a minus x over 2 and an x over 2 that will cancel out. I'll start from the bottom of BODMAS again and work my way up, and this time I get to an addition. So I need to take away this square root of y. Take away root y, take away the square root of y, and I'll be left with x over 2 equals 7 minus the square root of y. The plus square root of y and the minus square root of y will cancel out on the left. I'll start from the bottom of BODMAS and I'll work my way up to addition this time. So, division this time. What's the opposite of dividing by 2? Multiplying by 2. So I'll multiply both sides of this equation by 2 to give me x equals 2 times all of the right hand side. So I'll put it in brackets and it will then mean all of the right hand side. So this is the answer to this question. Alright, let's move on to the next one. So I'll follow the opposite order of BODMAS, and the first thing I've got to remove is the square root. And I'll do this by squaring both sides, because squaring and square rooting are opposites. So on the left hand side, y needs to be squared, and on the right, the square root symbol and the squared will cancel each other out. So I'll rearrange it to this. I can immediately see that x is negative in this expression, so I'll add the 2x onto the other side. Add 2x, add 2x. So it would be y squared add 2x equals 5. And now the next thing I need to get rid of is the y squared, and it's being added onto the 2x, so I'll take it away from the 2x. So take away y squared on both sides. The add and the subtract will cancel out. So I'll be left with 2x equals 5 minus y squared. And the last thing I'll undo is the times by 2. So I'll divide both sides by 2. On the left, the times by 2 and the divide by 2 will cancel. So it'll be x equals 5 minus y squared divided by 2. And there we are. That's the answer to this rearranging formula question. In this question, we've got 5 divided by all of x minus 2. So how do I rearrange this? Well, if you want to undo divide by x minus 2, how do you do it? If you're dividing by x minus 2, then the opposite of that is to times by x minus 2. So that's what I'm going to do. I'm going to put x minus 2 in brackets and then multiply it to both sides. On the left hand side, it will be y brackets x minus 2 equals, now on the right it's going to be 5 divided by x minus 2 times by x minus 2, and the two things will cancel out, so I'll just be left with 5 on the right hand side. You can do the following in the two different ways, but I'm going to expand the brackets. Xy minus 2y equals 5. Then I'm going to undo the take away 2y by adding 2y to both sides, so add 2y, add 2y, and that will give me xy equals 5 add 2y. And then the final thing, if I'm making x the subject, is to get rid of the y. It's being multiplied onto x, so I'll divide by y on both sides to cancel out the y that's being multiplied. So it's x equals 5 plus 2y over y. And another alternate answer would be 5 over y plus 2, or 2 plus 5 over y. Both of these answers are correct. You may have just done it slightly differently. Alright, let's move on to the next question. And the first thing I'll do with the left-hand one, make sure you've paused the video and given this a go, is to get rid of the big square root. And how do I get rid of a big square root? I do it by squaring both sides. So it's going to be y squared equals 7 over 2x plus 9. The next thing I need to do is sort out the fraction. Ideally, it's so much easier to rearrange formulas when everything's all on one line and there's no fractions involved. So I want to get rid of this fraction, and I'm going to do that by putting the whole denominator in brackets and multiplying it to the other side. 2x plus 9 and multiply by 2x plus 9. So what am I going to get here? It's going to be y squared, and then all of 2x plus 9 in a bracket on the left hand side, and then just 7 on the right hand side. The next thing I'll do is I'll expand the bracket, and it's going to give me 2x y squared. Now remember, when you expand brackets, it's always important you put the number first and then the letters in alphabetical order. It's just y that's being squared here, so the square must stay attached to the y. This is effectively saying 2xy squared is the same as 2x, 2 times x times y times y. It's only the y that's being multiplied by itself twice. And then expand the bracket with the 9 at the back, so it would be plus 9y squared equals 7. The next thing I need to do is take away the 9y squared, because that's being added onto the function with x in it. So 7 minus 9y squared. Then I can do two things in one go here. Onto x is being multiplied by 2, and it's being multiplied by y squared. So in the next line I'm going to divide by 2 and the y squared. So divide by 2 y squared. I can do that all in one go. And the answer is going to be x equals all of the things on the right hand side divided by 2y squared. And there we are. That's the answer to this question. Whoops, I forgot how we got this one, didn't I? So, in this question, we want to times by the denominator to move it all onto one line. It's so much easier to rearrange formulas when everything's on the same line. So I'm going to times by the denominator, which will cancel it out on the right-hand side, leaving me with just a. On the left-hand side, it's going to be y times b minus x. Then I'll expand the brackets, but I'm going to write out the expansion with the letters in alphabetical order. I'll then spot that the x term is a negative, so I'll add it to both sides. Add xy to both sides, add xy. On the left hand side I'll get by, and the minus xy will cancel out with the plus xy. And on the right hand side it will be a plus xy. I'm making x a subject, so I need to take away this a first. I'll do that from both sides. So on the left hand side it's going to be by minus a equals xy, because the plus a and the minus a will cancel out. The last thing I'll do is I'll divide by y, because it's being times onto the x at the moment. Divide by y, and that's going to give me by minus a over y equals x. And there we are, that's the answer to this question. Right, these questions are very, very tough. In fact, even Year 10 students and Year 11 students find these questions tough, and that's why we like to introduce them to you nice and early. Alright, so we're making x the subject here. Now, what's really important about making x the subject here is that when we say x equals, there cannot be any x's on the other side. So we have to group all of the x's together first. So, let's do that. So we've got 2x on this side and we've got ax on this side. And it's not obvious which side we should move the x's to. But what I can see here to make my life easier is I'll make the other letters positive first. And actually in this question I'm going to add c to both sides first. So I'm going to get 2x plus b plus c equals ax. Now that I've got everything else on the left hand side, I'm going to take away 2x onto the right hand side. So I'm going to get b plus c, so the 2x will cancel out on the left, equals ax minus 2x. So this is a really important point. What I've got at the moment is my x is on one side, and everything else that doesn't have an x in it on the other side. It doesn't matter that the x's are on the right, they could be on the left if that was easier. But in this case, just to make things more positive, I have moved the things without x in on the left. Otherwise, if I moved all the things without x on the right, it would be minus b and minus c. And I like to look on the positive side of life. So I like to make things as positive as possible. Now, once you've got all your x's on one side, we're going to do a little factorising trick. So this is bringing in the topic of factorising, because what you should be able to do with ax and minus 2x is spot that x is in both of them. So I can pull it out to the front of a bracket. And what will go inside the bracket? Well, x is going to need to multiply by a to make ax, and then it's going to need to multiply by minus 2 to make minus 2x. So I'm just going to concentrate on doing that on the left hand side. Leave the b plus c alone on the left hand side. Now, what you can see from line 3 to line 4 is I've converted two x's into just one single x, which is really helpful given that I want to make an equation or a formula which says x equals and then something on the other side without any x's in. It's really helpful that I've now converted it into one single x. The last thing I'll do is I'll divide by this bracket. So don't expand it at this point. Usually in these types of questions we're used to expanding the brackets to help us rearrange. In this case it is not a good idea because then you'd create two x's again. You don't want two x's, you want one x. So we'll divide this bracket onto the other side, so it would be b plus c divided by a minus 2, and then the times by a minus 2 will cancel out with the divide by a minus 2, and you'll just be left with x. So the final answer to this question is b plus c over a minus 2. And that's the final answer to this question. So let's replay it. What happens in this question? We moved everything with x in onto one side. In this case it was more positive to make that on the right hand side. Anything that doesn't have an x in it goes on the other side to it. Then you take the x side and factorise the x out to the front of a bracket. And make sure you put the correct things inside the bracket to make the line above work still. Then you divide by that bracket you've created to leave you just with x on the right hand side and everything else on the other side. And there we are, that's the answer to that question. So we go with this tricky one on the right hand side now. So let's make it all one straight line first. So I'm going to multiply by b plus x first on both sides. Multiply by b plus x. On the left hand side it becomes y times b plus x equals a plus x. Then I'll expand the brackets. Then I'll need to, now that I'm in a similar position to this question on the left hand side, I need to decide on a side to move all my x's onto. I think I'll decide to move them onto the left this time, just to give you a sight of doing it in two different ways. So I'll take away this x onto the left hand side, so that will cancel out with that, and I'll be left with a on the right hand side. On the left hand side I'll have by plus xy minus x. Okay, I've got all my x's on the left hand side, but this by is also on the left hand side, so that needs to move onto the left. So it's being added onto xy at the moment, so I'm going to take it away. I'm going to take away by from both sides. So that's going to leave me with xy minus x, because the by's will cancel out, and I'll be left with a minus by on the right hand side. Great. I'm effectively now at this position on this example here, because I've got all my x's in one place and anything that doesn't have an x in another place. And the next step from line 3 to line 4 in the previous example was to factorise the x side. So the side with lots of x's on it, put x at the front of a bracket and then work out what needs to go inside it. I need it to have a y to multiply by x to make xy, and a minus 1 to make it multiplied to make it minus x. Minus 1 times x will just be minus x. And now that I've got x multiplying by a bracket equals something, I divide by the bracket, divide by y minus 1 on both sides, divide by y minus 1, and I'll be left with my final answer, which is a minus by over y minus 1. Now if you've done this question slightly differently, you may have a different answer. An alternatively correct answer is by minus a over 1 minus y. That is also a correct answer, but no other answer is correct. Alright then, we've got a few more to have a go at here then, so pause the video and give these a go. On the left hand question, we're going to expand the brackets first. So AB minus AX equals C minus DX. And it's not at all obvious what side we should put the x's on. So I'm just going to pick the right hand side. So I'll add AX to both sides. Add AX, add AX. On the left hand side, that will cancel out with the minus AX, so I'll just be left with AB. And on the right hand side, it will be C minus DX plus AX. Great, I've got all my x's on the right hand side. Now I need to move that C because it's in the wrong place. I'll need to take it away because at the moment, this C is a positive C. So it's going to be AB minus C equals, now I've got minus DX and a plus AX. I'm just going to write that the other way round on the next line, just because I prefer things to be written that way round. Now that I've got to this position here, my x's are on one side, anything else on the other side, I need to factorise the side with lots of x's on it, because x is a common factor in ax and minus dx. Now what needs to go inside the bracket? It will be a times x to give me ax, and minus d to give me minus dx. And on the left hand side it will be ab minus c. The last thing I'll do is I'll divide by what's inside my bracket. So I'll divide by a minus d, divide by a minus d, and my answer will be ab minus c equals a minus d, so divided by a minus d equals x. And if you've done it a slightly different way, you may have a different answer. It might be c minus ab over d minus a. Either one of these two answers is correct. No other answer is correct. Let's move on to the next rearranging formulae question. And the first thing I need to do is get rid of this square root. So I'll square both sides. So it's going to be y squared equals x over 2 minus x. Now that I've got rid of the square root, I need to make everything on the same flat horizontal line. So I need to get rid of this fraction. So I'll times by 2 minus x, because it's being divided at the moment, times by 2 minus x. On the left hand side it would be y squared brackets 2 minus x equals, and on the right hand side the divide by 2 minus x will cancel out the times by 2 minus x. So I'll just have x left over. I'll expand the brackets here and I'll get 2y squared minus xy squared equals x. Now I've got x's on two sides of my equation here, so I need to move it onto the same side. And to make things more positive, I should move this negative expression onto the right hand side, because when I move it onto the right hand side, it becomes positive. And I always like to look on the positive side of things. On the left hand side, the positive xy squared will cancel out the minus xy squared, and I'll be left with 2y squared. And on the right hand side, it will be x plus xy squared. Now I've got all my x's on one side, anything else that doesn't have an x is on the other side. Now with the side that's got lots of x's on, I can factorise. Something with times x to make x, I just need a placeholder of 1 there, and then plus y squared to make it equivalent to the line above. Then I'll divide by what's inside the bracket, and that's the final answer in this question here. Alright then, we're going to move on to similar shapes then, and this is it's going to be question 11 on the end of year exam. And the question here is, these two shapes are similar. Find the lengths of x and y. Now what makes shapes similar? Well, there is a scale factor to get from the smaller shape to the bigger shape, or from the bigger shape to the smaller shape if you want to half something, or third something, or fifth something, quarter something, but generally I like to go from the smaller shape to the bigger shape. Also, an interesting fact about similar shapes is that all their angles are still exactly the same. Because if you imagine it, if you're on a computer screen here and you've just dragged the corner of the shape to enlarge it, then none of the angles actually change. It's just the lengths of the sides that have expanded by a certain scale factor. And the question is, how do we work out what that scale factor is? Well, we have to look for a common side where we have a number on both of those sides. And in fact here, 2 and 5 will help us work out our scale factor because they're based in between the blue and the red angles. So what would be the scale factor to get from 2 to 5? Well, you can kind of tell that it's 2.5, and if you can never work it out, then it's always the bigger number divided by the smaller number. So its scale factor equals big side divided by small side. And in this question, it's 5 divided by 2. And if you can do that on the calculator, or if you just know that 5 over 2 is equal to 2.5, then you know what the scale factor is. Okay, let's go from the smaller side to the bigger side here. How do we work out x? Well, this is a scale factor of multiplied by 2.5, so I'm going to do exactly the same thing with this side of 5 here. So x is equal to the side length of 5 scale factored up by 2.5 multiplied. So grab your calculator, and it's going to be 5 times 2.5, which is 12.5. So that side length of x is 12.5 centimeters. Now the side for y is a little bit difficult because we need to go from this 10 backwards to the smaller shape. So how do I decrease the size of this shape? Well, instead of making it bigger and timesing it by 2.5, I'll make it smaller and divide it by 2.5 because that's the opposite of timesing by 2.5. So for y, I'm going to take 10 and make it smaller by dividing by 2.5. So 10 divided by 2.5 gives me 4 centimeters. So y is equal to 4, x is equal to 12.5. So with these shapes, its scale factor equals the big side big side divided by the small side to work out your multiplier, and then multiply to get to the bigger sides, divide to get to the smaller sides. Okay, let's have a go at this question here then. So pause the video, make sure you've given it a good go. And the first thing I can spot is that the bases match up. So I can work out my scale factor by looking at the bases of this trapezium. In this trapezium, I need to do the big side divided by the small side. So 12 divided by 8. And 12 divided by 8 is the scale factor of 1.5. So I'm making things here 50% bigger. So it will be pretty easy to work out what the side y is, because that will be just multiplied by the same scale factor, because I'm making the whole thing bigger if it's similar. So y is equal to 6 times 1.5. So 6 times 1.5 equals 9 centimeters. And then for x, well, how do I go from a bigger side to a smaller side? I divide by 1.5. It's exactly the same scale factor ratio, but we're going backwards and we're doing the opposite. So we divide by 1.5. So 7.5 divided by 1.5 is 7.5 divided by 1.5 on the calculator gives me 5 centimeters. So x is a side of 5 centimeters. Okay, let's move on to the next question. Find the lengths of x and y. Well, how do I even know that these are similar shapes? Well, just a reminder, a couple of slides ago I showed you that similar shapes must have the same angles. And if you can prove that two triangles have the same angles, then it works in reverse and you know that they are similar. So let's go back to this question. Can we prove that these two triangles, one on the top and one on the bottom, have the same angles? Well, I know that these two angles are the same because of the Year 7 rule of alternate angles that you can make a z with, that these two angles are the same. Additionally, these two angles are the same here because they also form a z with the parallel lines on the top and on the bottom. We know that the top and the bottom lines are parallel because they've got these little arrows on them. They indicate that the lines are parallel, so you can make alternate angles out of them. And then by the angle rules of opposite angles are equal, then these two green angles are equal to each other. So you know that the top triangle is similar to the bottom triangle. But is it the case that 8 and y match up and 10 and x match up, or is it some other side to the triangle that matches up? We'll think about it like this. If we take the top triangle and flip it upside down, then it looks exactly like the smaller triangle. We've got the green angle at the top, the red angle in the bottom left, and the blue angle in the bottom right. So what does this tell us? It tells us that x matches up with the side of 8 centimeters, and the side of y matches up with the side of 10 centimeters. So what we need to remember is that x and 8 are in between the red and the green angles, and that y and 10 are in between the blue and the green angles, so those must match up, and so must the 8 and the 16 on the bottom, so the scale factor here looks pretty easy. Let's now put this triangle back, because that's how you're going to have to do the question in an actual exam. So what we'll spot then is that the sides in between the blue and the red angles must be equal. So the scale factor here is 16 divided by 8, which is 2. So the scale factor from one triangle to the other is a scale factor of 2. And if you also remember, it's the angle, so it's the side in between the green and the red angles that are equal to each other. So remember, it was we go from the bottom triangle to the top triangle and the scale factor. So actually we're going to have to go in reverse to get back down to x by dividing by 2. So x is equal to 8 divided by that scale factor of 2, which will give us a side of 4 centimeters. And then it makes sense because the side x looks smaller than the side of 8. And on the y equation, we're going to have to go back as well to get to y, and it's the side of 10 centimeters that corresponds to the side of y here. So for y, it's going to be 10 divided by 2 equals 5 centimeters. So this side here is 5 centimeters, this side here is 4 centimeters, and they match up diagonally in this shape. And the reason is because that's how the angles form. And you can kind of see that this is the shorter side on this triangle, and this is the shorter side on this triangle. So the two shorter sides must match up. This is quite a long side on this triangle, and it must match up with quite a long side on the other triangle. So make sure you match them up by actually how they look as well as thinking about their angles. Okay, so now that we've just been through that question previously, make sure you pause the video and give this good question a go. Okay, so we can see here we've got some parallel lines. So what that means is I can make Z angles out of this shape. Well, I know that these two angles definitely match up. We've got angle A here and angle A here. Then I can make a Z by this kind of shape here. So I know that this angle B here will match up with this angle B down here. And a backward Z could also be formed by this angle here and this angle here. So I'm matching up which two sides? I'm matching up the two sides in between A and C. 8 here and 12 here. They're both in between the angles of A and C, and they're also both the shortest sides on both the triangles, so therefore they should also match up like that. So the scale factor here is going to be 12 over 8, which is 1.5. So the scale factor between one triangle to the next is 1.5. Now to get x, we need to go from the 9 to this x here, and it was the smaller triangle to the bigger triangle in that case, so x is going to be made larger by multiplying by 1.5, and that will give us 13.5 centimeters. And similar with the y, the side y is in between b and c, same as this 10 up here, so it's going to be multiplied by 1.5 to go from the smaller one to the bigger one, so y here is equal to 10 times 1.5, which is 15 centimeters. And there we are, that's the answer to this question. So you're matching these sides up diagonally in these questions. Alright then, and a similar question here, well not a similar question, but another similar shapes question anyway. How do we do these sorts of questions here? We've got one triangle nested inside a bigger triangle. Don't think of this as one triangle and then a trapezium. Think of this as one triangle and then a bigger triangle, and one is nested inside the other. I'll show you what I mean by nested inside the other. Now, just before I move on to nested, I've got a green angle at the top here, standard. I've also got, by these parallel lines, some F angles involved, or some corresponding angles involved. This angle here and this angle here are equivalent to each other, and so are these two angles here. So that when I actually split up these two shapes, you can see the nestedness of it, whereby I've got one smaller shape and one bigger shape. So let's put that back and see it again. I've got 4 and y here, 5 and 7 here, but when I split them up, this side now becomes 4 plus y, and this side here now becomes 12, because it's the side of 5 plus 7. Okay, so what sides can I now match up? Well, I've got one big shape and one smaller shape. So I can spot that the angles, so the sides in between the blue and the green angle, match up. So my scale factor is equal to 12 divided by 5, which is 2.4. So my scale factor is 2.4 here. So if I'm going from the bigger shape back to the smaller shape, then I'm going to have to divide by that scale factor. 14.4 divided by 2.4, let's do that on the calculator, gives me 6 centimeters. So that's, what was that, x? Yeah, that was x. Now a trickier question is this side here, and to work out what y is. So I'm going to have to take the smaller shape, multiply it by the scale factor, and I get an answer of 4 plus y. So that's saying 4 times 2.4, that's this side, scale factored up by a scale factor of 2.4, equals the side length here of 4 plus y. And I've got myself a little equation here actually. On the left hand side, 4 times 2.4 gives me 9.6. But then I actually need to take away 4 to work out what y is. So my actual answer for y is 5.6. So there we have it. 6 centimeters here, 5.6 centimeters here. Alright then, I'll give you a chance to have a go at one without pulling the shape apart now. So pause the video and try and work out the length from A to D. That's this whole length from A to D. And then the length from A to B. Okay, so in this question I can spot here that I've got one angle up here, and then I've got these two angles that are the same. We might call those angles capital X. And I've got two angles down the side here, Y and Y, capital Y and capital Y. But the scale factor I can work out by going from 4 centimeters to 9 centimeters. Those are the two sides that I can directly compare. So 9 divided by 4, that gives me 2.25. So it's the scale factor enlargement of 2.25. So from the smaller triangle to the bigger triangle, I can now find A to D, because 5, A to D will be 5 times 2.25. Let's do that on the calculator. 5 times 2.25 gives me 11.25. And that will be the side of the bigger triangle from A to D. Lovely. And the second part is to work out from A to B. Now, A to B, what can I do here? I know that this is 4.5. I don't know what the A to B is. I might call this X. So the smaller side of X must be scale factored by 2.25. So it's going to be 2.25 times X, which will give me the whole length of the side from A to C, which will be X plus 4.5. Wow, this is actually quite a difficult question, this question from A to B. We need to make ourselves an equation. So you scale factor A to B up by 2.25, and you get the whole length from A to C. And that's what I've written here. Take X, scale factor it up by 2.25, and that will be equal to this whole side of X plus 4.5. Let's now take away 1x from both sides. Taking away 1x will leave me with 1.25x on the left. On the right it will leave me with 4.5. And then I'll divide both sides by 1.25 to get rid of the multiplier by 1.25. 4.5 divided by 1.25 gives me 3.6. So the answer to x, which is AB, is 3.6. Quite a difficult question, that one. Okay, so we're now going to move on to the final question that will appear on the Year 9 exam. It's a cumulative frequency style question. So pause the video, give this question a go, see how you get on with drawing the cumulative frequency diagram. Okay, so let me show you how to do it then. So the first thing we need to do is we need to add in that extra column for cumulative frequency. And what that means is add up the frequencies as you go along. So we'll start with 4. And what that 4 means is there are 4 somethings that weigh less than 50 kilograms. And then if I add on the next number, which is 7, I get to 11. And what that means is there are 11 somethings that are less than 60 in total. 60 to 50 and 50 to 40, there's 11 in total. Add on the next number, which is 21, and we get 32. Add on the next number and we get 53. Add on the next number and we get 71. Add on the next number and we get 78. And add on the next number we get 80. So a nice round number there. So what we're now going to do is we're now going to plot all of these cumulative frequency points with the points at the value at the end of the interval. Let's just take this 53 for example. What does this 53 mean? It means that there are 53 somethings that weigh less than 80 kilograms, because if you go from 80 kilograms downwards to 40, there'll be 53 items. 21, 21, 7 and 4 will add together to make 53. So it's always corresponding to the end of these intervals. So that's where we're going to plot them on the diagram. But the first point will need to be plotted at the first number in the intervals, which is 40, because there's nothing that weighs less than 40 kilograms. So we'll plot our first point at 40, 0. The next point will be at 54. So 54. The next point will be at 60, 11. 60, 11. The next point will be at 70, 32. The next point will be at 80, 53. The next point will be at 90, 71. The next point will be at 178. And the next point will be at 110, 80. That's perfect. Now what we do next is we connect all of these points together with curvy lines, and you've got to make sure that you go through all of these coordinates. Don't do a line of best fit. It's got to go through every coordinate, and you can be a little bit curvy. The next thing to do, so this is the cumulative frequency diagram drawn. The only thing I haven't done is actually correctly labelled my axis. This is a cumulative frequency up this axis, so make sure you don't forget to do that. And this is measured in kilograms. Oh, sorry, it's not measured in kilograms, it's measured in frequency, isn't it? There we are. Okay, so moving on to the next part, which is a box plot diagram. So how do we convert what we've got here into a box plot diagram? Well, the box plot diagram takes 5 different measurements. It takes the lowest measurement of 40 and puts a little marker there. It takes the highest measurement of 110 and puts a little marker there. Then we're going to do the middle, then we're going to do the lower quartile and the upper quartile. So how do we work out those values? Well, we've got 80 values in total. So if I want to work out the median, I'm going to do 80 divided by 2, which is 40. So it's the 40th data value. So I go to 40, I go across with a ruler, and I come straight downwards. And that to me nicely measures 73. And I'll put a little 73 there, and then I'll put my marker at 73. So what I'm saying there is that the median of my data is exactly 73. Or you could say that half of the somethings that we've weighed here are less than 73 kilograms, and half of them are more than 73 kilograms. The next thing we're going to do is do the lower quartile. And when it's a lower quartile, we're dividing it into 4 different parts, into quarters. So we do 80 divided by 4 is the 20th value. So go to 20, go across, and go down. And I got about 65 there. Might have 64, might have 66. We'll give you some leeway in the exam, but try and be as accurate as possible. And then the final one, which is the upper quartile, will be the 3/4 way mark, and you can just add these two together to get the 60th, because when you add a quarter and a half together, you get the 3/4 way mark. So it's going to be 60 to there, and then all the way down. Now please make sure in the exam you actually do that with a ruler. I'm just working on a stylus and tablet here, so it'd be a bit difficult for me to do that. But in the exam, there's no excuse for you not drawing those lines with a ruler, so make sure you do. I've got that at 83 exactly. Now once we've got the lowest value, the lower quartile number, the median, the upper quartile, and the highest, we now make ourselves a box in the middle, and then some whiskers to the outside. And sometimes this is called a box and whisker diagram. And that's why it's a box in the middle and then whiskers either side. So there we are. That's how we draw a cumulative frequency diagram with a box plot diagram underneath it. So now you've seen me do one, now it's your turn to have a go at one. So pause the video and give this question a go. Roughly the same data that we used before, but I want to see you do it now. Okay, so let's go through this question then, and hopefully you've got this one right, and hopefully you've looked back at the previous example and made sure you've got this one right. But let me just show you to make sure. Cumulative frequency column first, 3, 11, 30, 53, 73, 78, 80. So this data goes up to 80. So the next thing I need to do is plot my points. Well, first point will be at 40, 0. Always your first coordinate is in the corner at 40. The next point will be at 50, 3. So 50 along, 3 up. The next point will be at 60, 11, because there are 11 pieces of data less than 60 kilograms. So 60, 11. There are 30 pieces of data less than 70 kilograms. So 70, 30 would be the next marker. Less than 80 are 53 pieces of data. So 53 will be marked at 80. 73 pieces of data less than 90. 78 pieces of data less than 100. And 80 pieces of data less than 110. All of our data. So you connect them up with one continuous curvy line that must go through every single coordinate. Don't do a line of best fit, do it a curvy line through all of the coordinates. Now we need to put a marker at 40, the lowest point, a marker at 110, the highest point. The middle point, well, there are 80 pieces of data, so the median will be at the 40th piece of data. So I'll go up to the 40th piece of data, and I'll go across, and then I'll go down. And that's at 74. So I'll put a little marker down there at 74. The lower quartile will be at the quarter way mark. And what's a quarter of 80? 20. That'll be the 20th piece of data. So I'll go to 20, across and down, and that'll be at the 64th piece of data. And then the upper quartile will be the 3/4 way mark. 3/4 of 80 is 60. You could do a quarter and a half. So it's 60 pieces of data, and then down. So that would be at 83. Now, do you get some leeway in the exam? Yes, you get some leeway, but you still have to be as accurate as possible because it's not much leeway. Maybe it might allow you to do 82 or 84. If it's generous, 81 and 85, but it will not allow you to do 80. If you've got it down at 80, you need to draw a more accurate cumulative frequency diagram, and this is our box plot diagram underneath. Alright, so let's now move on to answering some questions about cumulative frequency diagrams. So the diagram shows a cumulative frequency diagram of heights of 80 sunflowers. Find the interquartile range. So what's the interquartile range? It's not the range. The range would be the highest, take away the lowest. It's the interquartile range, which is the upper quartile, take away the lower quartile. So I'll need to find these numbers first. If I've got 80 pieces of data, then I'll need to go to 60 for the upper quartile. Gosh, that's a tiny box there. And that for me is at 172. And the lower quartile will be at 20. And that for me is at 134. And now you do the subtraction. 172 take away 134, which is 38. So the answer to what is the lower quartile, the answer is 38. Part B is how many sunflowers were under 120 centimeters tall. Okay, well we can use the cumulative frequency diagram to tell that answer. We go to 120, we go up and along, and that it will be at 12. So there were 12 sunflowers less than 120 centimeters tall. So 12 sunflowers. And the next question is, how many sunflowers were over 180 centimeters tall? Well, once again, we can use the cumulative frequency graph in reverse. Go from 180 upwards with a ruler. And you'll get to 68. But it says the amount of sunflowers over 180 centimeters tall. So that would be these sunflowers, that would be these sunflowers, so that would be this amount here, and 80 take away 68 is 12 sunflowers again. Just a coincidence that those two answers are the same there. Okay, so there we are, that's the answer to this question. Okay, let's move on to answering some more questions about cumulative frequency diagrams. In this diagram, the diagram shows a cumulative frequency diagram for the cost of a Cyprus holiday for 120 customers. Estimate the median cost. Okay, well I've got 120 pieces of data. The middle person would be the 60th person. So let's go across and down. So I would say 700 euros. How many customers spent less than 500 euros? Okay, well I'll go to 500 and I'll go across, and that'll be at 28 because each little box is 4. So it's going to be 28 customers spent less than 500 euros. And how many customers spent over 100 euros? Well, all of them spent over 100 euros, so this was probably meant to read 1,000 euros, so I'll do that question instead. So it's going to be from 1,000 going up, and then across, it's 2 boxes up from the solid line, so that's going to be at 108. But that's not what the question is. The question is spent over 1,000 euros, so that will be 12 customers that spent over 1,000 euros, because that would be over 1,000 euros, so they'd be these customers, so it would be this portion above 108. There we are, that's all we're going to go through during these end of year exam revision videos. You've covered all of the content through the end of year exam, so feel free to go back and study any of the videos you've already previously done. Pick your weakest topic and have a go at those questions again. There's nothing wrong with doing questions again, because it reinforces in your brain how to do certain techniques. But I hope you found these videos helpful. Hopefully you do well in the end of year exam if you've carefully studied these videos. And good luck!